So good morning, good afternoon, good evening, based on wherever you are. It's my pleasure to welcome you to another episode of the YugabyteDB Friday Tech Talks. I'm Kannan, co-founder at Yugabyte, and it's my pleasure to welcome Ram Kannan, early engineer on the team, who will be doing today's tech talk. Would love for him to introduce himself. Maybe Ram, just share a little something about yourself before you get into the topic.
Sure, thank you. So, hi all. Good afternoon, morning, good evening, wherever you are. My name is Ram Srivatsa Kannan. I've been with Yugabyte for the past 2 years, slightly less than 2 years, and it's been an amazing experience. I come from a traditional computer architecture background, but learning databases and distributed databases specifically, I found it very, very exciting, and it's been an amazing journey for the past almost 2 years.
And what are the kind of things you've been working on, Ram, at Yugabyte?
Definitely. So Yugabyte, I mostly work at the query layer, specifically the YSQL or the Postgres equivalent relational database management query layer in Yugabyte. Some of the projects that I've been working on is memory management, query planning, query optimizing, improving the performance by choosing best query plans, things like that. And today's talk also is going to touch on some areas in that regard, and I'll be happy to actually share what some part of the work that I've done during my tenure at Yugabyte.
Yeah, I mean, today's topic, the PG hint plan, is something that you have worked on. Thanks for enabling that in Yugabyte. Yeah, let's get started.
Sure, cool. I'll share my screen. Great. I hope you guys you're able to see my screen, right? Yes.
Yeah.
Great. Awesome. So so today's talk is going to be about optimizing queries using PG hint plan PostgreSQL extension, right? So before even I go deep into PG hint plan, I'll just give a brief overview about the YSQL architecture. Right? So why the Yugabyte, as we all know, is a distributed database architecture. It is a multi-node database where each node can have 0 or more YB master, and each node has a YBT server. While the role of master is more on the load balancing and orchestration side, the core component of the Yugabyte distributed database architecture is the YBT server, which actually executes the any SQL queries. And specifically, the YBT server has two major components: one, the query layer, and the DocDB storage layer. Going more into the query layer, right? The YBT server hosts multiple APIs to execute database queries. The YSQL, the Cassandra query layer, the YSQL, which specifically uses Postgres style semantics to execute relational database management queries. Right? As similar to Postgres, the YSQL query layer contains its own postmaster process, which spawns for each connection, each YSQL connection, a Postgres backend, which is a separate child process of the postmaster. And the postmaster, again, is a child process of the YBT server, going bottom to top, right? So every YSQL connection, just like a Postgres connection, executes a bunch of functionalities like query rewriting, query planning, query execution, query optimizer, etc. Specific to PG hint plan, the thing that is more of interest to this talk is the Postgres query planner, right? So the typical functionality of any query planner, specifically for Postgres query planner, is to create an optimal execution plan for queries. And let me explain that with the help of an example, right? So assume you have a very simple table containing two columns, ID and value, both being integer-based columns. The ID is a primary key of this table, and correspondingly, if you look at the list of the index, you have a T1 underscore primary key being the primary key index. And you have a couple of secondary indices, T1 underscore val, which is the secondary index on the whole column value, and T1 underscore val underscore 2, which is a partial secondary index where value is just equal to 2, right? So let's say we execute a very, very simple thing, explain, select, yes.
Ram, maybe just to add one detail, because in case the listeners are not familiar with the concept of partial indexes, Postgres has this property where you can say that instead of indexing all rows for a particular column, I only want to index, say, the value column when a certain condition is met. So the create index statement allows you to specify expressions like where val equals to, or more commonly, somebody might say where value is not null. Like suppose you have a phone number column that is like, let's say 90%, it tends to be null, maybe because your users didn't supply it. So you can say that you want to create an index on the phone number column only when it's not equal to null. So that's sort of the example of the third index that you see in Ram's slide.
Yes. Thank you for explaining that, Kannan. So yeah, as Kannan told, and these users tend to create multiple such partial indexes based on the frequently used row values of any column, right? So continuing from there, so if you want to do a simple index lookup query, like explain select val from T1 where val is equal to 2, right? What the Postgres query planner will do is it will use what is called a cost-based optimizer to calculate the cost for every single query plan that is possible, that can potentially exist, and take the query plan that has the lowest cost to execute this query. And in this case, you could see that it uses T1 underscore val underscore index. However, there is an alternate query plan where it can use the partial index, right? Because your where clause in this particular query says where val is equal to 2, and you have a specific index that called T1 underscore val is equal to 2, where val where it is a very it is a it is a partial index, right? And that can lead to a more optimal execution, query execution, where the query execution could take much lesser time. But because of the fact that the Postgres cost-based optimizer assigns a lesser cost, in some situations, forces the query planner to take T1 underscore val as an index, right? And this can be a problem at certain situations, right? So to curb this issue, right, PG hint plan, Postgres SQL extension can help curb this issue. So basically, the functionality of PG hint plan PostgreSQL extension allows users to provide hints to the planner in order to control the execution plan of a query. Specifically, what it does is that it provides hint to the query planner to actually consider an alternate query plan, overriding the cost-based optimizer's feedback to provide an alternate query plan, and which is provided by the user at a query level granularity, right? So in other words, users can use hinting phrases of a special form, like comments, that is embedded along with the query to actually provide these hints. Like, let me explain that with the same example. For the same sample table, say if you provide a comment saying index that starts with /* and providing the hint to use index scan on the table T1 with the value with the index T1 underscore val underscore 2, if you use this specific hint phrase along with the query, what it means is that PG hint plan is instructing the query planner to actually use the preferred index T1 underscore val underscore 2 in contrast to the default index that is being provided by the cost-based optimization. Like any questions before I move further?
No, not yet, Ram. But I think it's worth clarifying that by and large, the default plan picked by the database, should do the trick. Especially like as for example, Yugabyte's cost-based optimizer continues to improve, and we are making more progress on that. Also for simplistic queries like OLTP queries, usually the optimizer will just pick the right plan. We should view the PG hint plan mechanism as more of an exception that allows you sometimes to control this at a finer grain level, maybe because the app has more knowledge of like which index is likely to be more selective and so on. So this is to be used in a more controlled and careful manner rather than the solution for all situations.
Yeah, it's a great point, Kannan. So with that, right, the next part of this talk is for me to actually enumerate the list of all features that PG hint plan provides to their users and go over a few of examples explaining each of those features. Right. So one of PG hint plan's most important features is PG hint plans can be used to leverage. It can be leveraged to control scan methods, join methods, and joining order. So, for example, we have seen from the previous example that PG hint plan can use to actually control scan method by specifying the index to use. Right. Similarly, PG hint plan can also be used to control whether a query would want to use a nested loop join or a hash join or a merge join. Right. Sometimes table sizes can be too large, and analysts might not have updated table sizes, and the cost-based optimizer might use a specific join method, assuming a different size of a table, and in that case, right, you can PG hint plan features can be actually used to override them. And last, most importantly, PG hint plan can actually control the joining order of a query. Right, and I have a much more detailed example explaining this. So this will be covered in the later part of the talk. Right, in similar fashion, like users can also leverage PG hint plan to tune query level memory utilization or to actually set GUC plan and method configurations. Right. So, for instance, Postgres has a working set of memory that can be assigned to every Postgres session. This using PG hint plan, that working set of memory can be made more fine-grained at each query level. Right? And I have an example to actually show this too. And lastly, right, writing comments for every query could be very cumbersome, right, to actually enable PG hint plan. Right, these queries can be part of auto-generated code, and changing that could be require a bunch of review process and things like that. And in order to actually avoid those situations, there is a feature called hint tables, using which you can make PG hint plan much more accessible to users without even adding comments. And again, there is an example in the future slides to actually explain that too. So I just want to actually go over all these 6 different examples to actually show what the list of features PG hint plan provides. Okay. So the first features, as we already saw, that PG hint plan can be actually used to specify a bunch of scan methods, and these are a list of all capabilities that PG hint plan provides to users in the context of scan methods. Like, say, for example, users can specify, force a query plan to use a sequential scan or an index early scan, etc. Right? So let me provide another example, right, for PG hint plans, where PG hint plan can control the scan method. Consider this table, right, T3. It's a similar table where you have a primary key index on ID column, which is an integer-based column, and you have another column called val, and there are multiple indices on val. T3 underscore val is a whole index. T3 underscore val underscore 2, val underscore 3, and val underscore 4 are 3 different partial indexes where value is 2, 3, and 4 respectively, right? And right, let's say we have this query, select count star from T3, where T3.val is equal to 2. As we saw in our earlier example, that it uses the T3 underscore val as an index for this table T3, right? And even if we change the value to 3 or 4, it uses the default secondary index T3 underscore val, right? However, we have specific partial indexes for all these three situations, right? So with PG hint plan, in addition to specifying a single index, what we can also provide is a list of indices, right? Where we can instruct the user or instruct the query planner to say, instead of using just one index T3 underscore and val T underscore 4, we can instruct the query planner to say, hey, use any of these indexes, val underscore 2, val underscore 3, or val underscore 4. And now the cost planner can pick among these indexes, and here it uses val underscore 4 as an index, and the other example it uses val underscore 3, and the other example it uses val underscore 2. Right now this feature enables users to use a list of indices. Right. So any other questions before I move to join methods? Can I move forward?
Yes. So there was one question
Sure.
from Krishnakant Ketan who asked, can you run analyze instead of explain for the same query and see if you get the same plan? So this is the analyze feature that is in beta. That's what's being asked about now.
Sure. So I think the first part of the question is these queries have been run after the analyze feature, which is in beta, has been run. Second thing, is he specifically asking about running instead of cost false, explain, analyze, select, count star? The answer to this question is yes, it will provide the same query plan. The reason why I removed cost is equal to false is that the slide might become very cluttered with having a bunch of cost numbers. And for a few examples in future, I've also run them with explain analyze to show what costs executing a particular query will incur, and I'll show those examples with a few other queries.
Yeah, maybe I can just clarify. I think the analyze capability itself is something we plan to cover in a separate talk, but it is fair to say that by default, the database assumes that every table has about 1,000 rows, right? And the index has certain selectivity. It's more of a beginning assumption about what the table sizes are. But once you run analyze, the system updates its knowledge of like, what are the sizes? Hey, this is actually a 1,000,000 row table versus the other one is like, a small, 1,000 row fact table. And now that is also a different path. Like once you run analyze, the default plan picked by the system itself is good, that you need to rely less and less on the hint plan mechanism. So that is definitely a different topic we'll cover. This one is assuming like you're not happy with the plan generated by the system, giving you a way to override that mechanism. Go ahead.
Cool. So I think these are plans that that could be generated even after analyze has been executed. I'll show you an example specifically in that regard. Right. So now that we have talked about scan methods, I'll also show you a simple example where using PG hint plan, we can enforce a specific join method for SQL statements. Right. So for instance, we have two tables of same schema, ID and val, and we just have the primary key index, no special indices, right? And the first table has 10,000 rows, and the second table has 1,000 rows, right? And if you are trying to do a join of these two tables on their primary keys, right? So we execute this query, explain, analyze, select star from T1, T2, where T1.id is equal to T2.id. The join specifically is on the primary key, right? So what we could see is that instead of the default execution plan uses a nested loop join, right? Instead of nested loop join, if we force the query planner to use hash join, right, we can see that the execution time is much more lesser. We have a decreased set of execution time. And you can see that the default cost that is assigned for nested loop join, you see, is around 210 here. But for hash join is 1138, right? Hash join, the query planner estimates that hash join will incur more cost. But in reality, the execution time is lesser. And this is one situation where the query plan potentially picks a poorer plan, right? So moving forward, one of the more interesting examples here is with respect to join order, right? And again, let me take 3 tables instead of 2 here. We have 3 different tables where table 1 follows the same schema of the all 3 tables follow the same schema. Table 1 has 10,000 rows, table 2 has 1,000 rows, and table 3 has 100 rows. And now we are trying to actually execute a join on table 1, 2, and 3, right? So as expected, the default execution plan is the nested loop join execution plan. And specifically, the nested loop join plan has the innermost table as the largest table, the second innermost table as the second largest table, and the outermost table as the smaller table, right? So slightly going deeper here, the reason why a query execution plan takes the largest table as the larger table as an innermost table is that a join can be viewed as an execution of a double for loop, right? If you have a outer for loop that runs on 0 to 100 and inner for loop runs on 0 to 1000, where your matching condition, what you end up doing is for every 100 elements in the outer for loop, you perform seeks on the inner for loop, right? And so typically these get translated as 100 SQL queries to which match the join condition that is specified here, right? So now what you have is T1 is the inner loop and T2 is the outer loop, and you execute 100 seeks on the join conditions, and you get a T1 intersection T2 which has 1,000 rows. And again, you go one step further and you actually try to join T1 intersection T2 and T3, and that join results in 100 rows. So the first operation, T1 underscore T2 runs 1,000 seeks, and the second operation, T3 joining with T1 intersection T2, there's 100 operations. And that's why we execute the following query plan. Well, this is a reasonable query plan. If we flip T2 and T3, what we are resultant is that when T1 is joined with T3, what happens is that we just execute 100 seek operations, and T2 with T1 intersection T3 again does a 100 seek operation, and this ends up incurring much lesser number of seek operations than the original query plan. As a result, you can clearly see that the optimized execution plan with PG plan that specifies the leading join to execute is T3, T2, followed by T1, incurs much less execution time than the default query execution time. Right? And this is one of the optimizations that can be actually done while using PG plans to alter join orders. Is there any questions? Sure. Can I continue?
Yes, I'll let you know if there are questions. Yeah, go ahead.
Sure. Thank you. Good. So the next feature that PG plan actually leverages users to actually use is to set work memory for at a query level granularity. So assume the same example where we actually join 2 tables. There can be different situations where some tables are very, very small and some tables are very large, right? And Postgres has, based on what I know, I think Postgres has a default work memory size for every session that it allocates. So users can actually control the amount of memory that a particular at a query level granularity using PG hint plan hint phrases, right? What this leverages users to do is when you know that a particular join table is quite small, you can allocate much lesser memory for certain queries so that the leftover memory can be used by other Postgres processes. And this is using PG hint plan to set that is one way to is much more fine-grained than using session variables to do that. And so similar to setting work map, you have a bunch of GUC planner method configurations that can be set at using session variables. PG plan lets users to set these configuration parameters at a query level granularity. For instance, if we want to disable index scan, we use this hint phrase, enable index scan to be off. So this join query that we are executing is forced to actually use sequential scan on all its table. Cool. So there are a bunch of GUC planner method configurations, and the list of all those configurations are given in this table. And these are some of the configurations that users can use as a part of their query. Yeah, at query level granularities. Cool. So the last feature that PG hint plan provides users with is the hint tables, right? So the reason why hint table exists in the first place is that adding comments to every query becomes very cumbersome. So assume if queries are part of a Java application, right? In order to actually add these comments as a part of your query, you have to go and make code changes for this application. It has to go through a review process, and then once the binaries are generated, you have to replace it with the older binaries, and that could be for some situations it could be more cumbersome. And in order to avoid those situations, hint tables is a very convenient way by which you can actually group queries of similar type and enable PG hint plan for them. So basically what we have is that we have these grouping information stored in a table called hintplan.hints, right? So assume this query explain cost equal to false, select star from T1, T2, where T1.id is equal to T2.id, and uses a nested loop join. We already know from our prior examples that we can use hash joins to actually enable a much more optimized query execution plan, right? And instead of adding this hash join as a hint phrase, what we can do is we can insert into hintplan.hints the hints that we want to use, that for queries of this type, use hash join. So this avoids users to actually specify these hints as a part of phrases. Right? You can just add them into hint tables, and whenever these queries are executed, the planner checks the hint table to see if queries that exactly match these phrases are present, and if those phrases are present, then it picks up the hints that is provided as a part of those phrases, right? So after adding this into the hint table, if you execute the explain plan, you could see that it automatically reverts to using hash join even without the hint phrases being present. And an important aspect of this is that the hint phrases should match exactly the normalized query string that is present as a part of your application query, should match verbatim with the queries that are inserted into the hint plan hint tables, right? And if it does so, it will just take the hints that is provided here in this example hash join, and apply this to those queries. So these are the list of features that PG hint plan provides for users to actually alter query plans. I'll be happy to actually answer any questions that you guys have. Yeah.
Hi Ram. There is quite a bit of lag, looks like, in the LinkedIn Zoom to LinkedIn Live relay, because right now what I see on the LinkedIn Live is it's still on the setting working memory example. So we have a few slides behind. It's on that slide. So the questions may not be coming in as real time as we think. But one thing I would ask is maybe just if you could speak for 30 seconds or so on how was this implemented? Because it's a Postgres extension where we're able to repurpose that extension pretty much as is. If you could give some insights into that, that would be helpful.
Sure. So yes. So as I briefly mentioned in the architecture slides of Yugabyte, Yugabyte uses a Postgres API, and by means of Postgres API, we actually import a bunch of Postgres code as it is and make some modifications for it to actually interact with the Yugabyte specific DocDB storage layer. And since we actually import the Postgres layer as it is, any extension that can be actually added as a part of Postgres can also be added within Yugabyte framework, right? So PG Implant is one such extension, and because extensions can be tagged along with Postgres, we could also with very simple code level implementation specific modifications that are more specific to Yugabyte, we could easily tag in the PG Implant extension along with the Yugabyte source path, and we could get this at a quite cheaper cost.
Yeah. And also like with less surprises, because the functionality pretty much
Exactly
matches the functionality that you would expect with just traditional Postgres. It would be very similar. Like, for example, I think one question somebody asked earlier was, if there are two tables with the same name in your query, maybe they're just in two different schemas. How does the hint system, do you schema qualify the table name, or do you say s1.t and s2.t, or do you do something else?
That's a great question. Yes, you can schema qualify the table names.
Inside of the hint syntax, would that work?
Yeah, I think that would work, but more specifically, right? How this should be approached is that every query, right? So PG Hint Plan has the capability to actually use hints on aliases of tables, right? So in that situation, if there is some confusion in terms of qualifying schemas or having similar table names, what the users can do is for every table name, even if it's equal or unequal, they can apply, they can actually use aliases for each table name that is present in the database and insert into the hint plan hints table queries with the hint phrases that consist of the aliases. And if the aliases are unique, the hint table will automatically pick up those hints.
Got it. So using table aliasing in the SQL syntax, that makes sense.
Yes.
There's one other question that has come in, which is like, in the hints table, suppose your statement, suppose people are using literals in their statement, like where ID equals 5 or ID equals 10. But you want to say where ID equals sort of question mark, like a wildcard match, right? So is it possible to insert into the hints table with like ID equals $1 or something like that?
So absolutely. So when you have string literals, where clause can say where ID is equal to 1 or 2 or 3, you can have a question mark, and that is one feature that PG Implant supports. You can absolutely use that, and you can specify since it's a where clause, and if it's an index lookup, you can specify which index to use as a part of executing this query. Those things can be absolutely done. Yes.
And we will take one final question. So that one is, does Yugabyte right now support auto_explain extension to capture historical explain plan of the queries? If not, is there any plan to add this feature?
Yes. So adding this feature is present as a part of Yugabyte's roadmap. It's a great question. So one of the it's still a work in progress. In fact, I have submitted a diff to actually add an auto explain feature in Yugabyte. One of the issues there is that it executes a load on, it requires a load command to actually load a bunch of shared libraries. Right? And the way Yugabyte works is that though it is a distributed database, the postmaster service is specific to every node. And distributed loading of shared libraries should happen in, and we are still working on how load should work in a distributed environment, whether a single load should execute a single load on shared libraries, should load the shared library on all node, how do you replicate across different node, how do you maintain transactional semantics there, and things like that, right? So once that feature has been finalized, which is currently in the design phases, then auto explain can be easily added along with that. Does that make sense?
Yeah, and no, that makes perfect sense. Great. So thank you very much, Ram. I was incorrect about the delay on the LinkedIn Live. It was more like, I think maybe my other screen wasn't refreshed or it was lagging. But when I reloaded the browser, I don't think there was that much delay. That was number one. Also, next week is 1 week where Yugabyte has this quarterly wellness day. So Yugabyte employees are off next Friday. As a result, that will be the first week in this year on a Friday where we will not be having the YugabyteDB Tech Talk. But join us 2 weeks from now for the next session. Thank you very much for all those that attended. And thanks a lot, Ram, for this talk.
Thank you very much, Kannan. It was a pleasure talking to all.
Great. Thank you.